Welcome you all. I just come up with a question from kinematics of a rigid body. The rotor of an electric motor is rotating at a speed of 720 rpm when the steam supply is suddenly cut off. It is observed that 5 minutes are required for the rotor to come to rest, assuming uniform acceleration. So, formula needs to be used based on the uniform acceleration and the angular acceleration, the total number of revolution need to be found. This is the task. So, given, what is given? The speed is given, which is n 720. Okay. So, initially which is running at this speed. So, I just going to take which is the initial one. So, speed at the initial which is n naught, and then it is cut off, then it will be coming at an end which will be I can say 0. Speed will be 0 when it is at the end, because that time after cutting off the power supply, then it will be what the speed, it will be comes to an end. Am I right? There won't be any rotation, so it will be 0. Then it is observed that 5 minutes is required for the rotor to come to rest. So 5 minutes is taken. Okay. So time taken which is t, 5 minutes. So always we need to just keep the time in second. Okay, standard format. So in order to convert it, t which is equal to 5 into 60. Minute to second, in order to convert we have to multiply with 60. So here we get 300 second. Okay, 300 second. So to find, so A is alpha acceleration, angular acceleration, and B is the total number of revolution. Okay, total number of revolutions. These two things we need to find. So in the solution part, in order to identify the first one, alpha, okay, angular acceleration, what I'm going to do is I just take, it is a uniform acceleration. So we know uniform acceleration formula here, which is omega, which is equal to omega naught plus alpha t. Am I right? So from this I just going to take the alpha. Okay, I just going to use this one. So omega which is equal to naught. Okay, omega, just omega which is equal to omega naught plus alpha t. So which is unknown. What about omega? Omega in the sense it's an angular velocity, right? At when it is coming to and rest, it is the final position. So omega at a final stage which will be a 0, angular velocity will be 0. There won't be any speed or velocity since it is coming to rest. Okay, so it will be 0. Okay, fine. Omega 0, fine. Omega naught we need to find, because here speed is given, not the angular velocity which is absent here, right? So that we need to find. So alpha is the thing we need to find it. So omega naught angular velocity, which can be followed by the formula angle covered in one revolution into number of revolution per second. So that means 2 pi n divided by 60. So here if I substitute 2 pi into n naught, okay, it's a initial one, n naught, which is 720 divided by 60. So which is equal to, if you put the calculation, I can say you may get the answer for omega naught 75.4. okay, so radian per second, right? So now this formula will be omega which is equal to omega naught plus alpha t, that can be noted as 0 which is equal to 75.4 plus alpha into t which is 300. So this will be, so if you just uh, simplify it, I can say alpha, which is equal to, when you take it to the next side, it will be minus 75.4 divided by 300. Okay, so at that time you will be getting the value as alpha, which is equal to minus 0.251 radian per second square. Okay, so this minus sign actually indicates the angular velocity, which is the retardation. Okay, which is the retardation. And then coming to the B, total number of revolution. So in order to identify it, I just going to take the formula. Okay, theta. So here we have formula with respect to a theta displacement, okay, which is equal to omega naught t plus 1 by 2 alpha t square. The same formula I just going to apply here. So theta, which is equal to omega naught t plus 1 by 2 alpha t square. So here when you substitute omega naught, we have identified 75.4 into t is 300 plus 1 by 2 alpha, and alpha answer we have found it. Okay, so which is minus 0.251 into 300 square. Okay, so when you put it, you will get the answer as 11,325 radiation. Okay, radian, 11,325 as an answer, which is a theta, it's a displacement. Okay, this is an angle of displacement. So here our requirement is total number of revolution. How will you find it? So entire angle taken or displacement taken is 11,325. So if you want to find the total number of revolution, I just going to divide it by 2 pi. Okay, so why because one revolution, which is equal to 2 pi in terms of radian, we used to say. Am I right? One revolution is 360, which is in terms of degree. Okay, if you want to take in the radian, which is a 2 pi. So one revolution, which is equal to 2 pi radian. So what I going to do is I just going to divide it, so that total number of revolution which is equal to 11,325 divided by 2 pi. I will get 1802.43 revolution. Okay, so this is the total number of revolution taken in the motor. Okay, so I hope you understood how to calculate when you are having such kind of questions. Okay, it is so easy, just directly substitute the formula in the logical manner you need to find. Okay, so here the identifying which value is the initial and which value is the final will plays a bit difficult role, but it is easy. Here the motor is rotating at a speed of 720 rpm, which is given. So initially, which is at 720 rpm, when the supply is cut off, when the electrical motor supply is just cut off, then it will be coming to the end. That means it is moving to the rest position, so it will be the final one. So here the speed at the final and angular velocity at the final I have taken as 0. Okay, so that's why it is taken as a 0. So in a logical manner, if you just take the given data, and it will be easy when you are applying the basic formulas of equation of motion, we shall identify the unknown things. I hope you understood. Thank you so much.